Okay, hopefully this lesson's a little smoother than the last one. This is Unit 10, Lesson 5. So first paragraph just introduces you to the lesson. We'll go right to the exercise. I am pressed for time. So algebraically determine the y-intercept for the function given. So f of x equals x plus 6 over x minus 3. So a y-intercept is when x equals 0. Well, so much for that. X equals 0. So that's your y-intercept. So if you just plug in 0, wherever you see an x, you are going to get 6 over negative 3, which is negative 2. That's your y-intercept. Done. Okay. Part B, algebraically determine the x-intercepts of this function. So if I have an x-intercept, that means that y equals 0. So I have 0 equals x plus 6 over x minus 3. 0 over 1, cross multiply. 0 equals x plus 6. X equals negative 6. That is your x-intercept of the function. For what value of x? Undefined. So when it's undefined, that means that the denominator equals 0. So the denominator is x minus 3 equals 0, x equals 3. That is where it is undefined. Okay, so then part D, based on C, state the domain of this function in set builder notation. So your set builder notation, x such that x does not equal 3, because it can equal every other value. Exercise 2, find all values of x for which the rational function is undefined. Verify by using your calculator to evaluate this expression for these values. So undefined again, it's when your denominator equals 0. So quick little review on arcing. So you have your a times c, which is negative 12. Okay. Factors of negative 12 that give me an 11 are 12 and negative 1. 2x squared minus 6 comes down, plus 12x minus x minus 6. Group the first two, group the second two. 2x, x plus 6. Take out a negative 1, x plus 6. So then you have 2x minus 1, x plus 6 equals 0, x equals 1/2, x equals negative 6. So that is where the function is undefined. Verify your calculations in the calculator. So go to your calculator, and we will go to the main screen. I will pause this. Okay, I'm back. You didn't even know I was gone. So here we are. Put in the calculator, verify. So you put in the original expression, x plus 5 all over 2x squared plus 11x minus 6, such that x equals 1/2. Enter undefined. Okay, bring it down again. Back it up. Put in your negative 6. Enter undefined. Okay, so that's how you verify using your calculator. Now the last one here, which of the following represents the domain of the function? So that means that we have to set x squared minus 6x minus 16 equal to 0, because that's where it is undefined. So just go to your calculator, all right, and do your menu 331, okay, and plug in 1, negative 6, negative 16, enter, negative 2 and 8. So negative 2 and 8. So that means that negative 2 and 8 do not work. They make it undefined. Therefore, it is choice 3. Okay. Exercise 4, composition of functions. Because you have the f and the g, and you're trying to evaluate. So you have composition of functions. So the first one you have to do, remember you do the one in parentheses first. So you have g of -2. So this -2 has to go in for the x in g of x. So you have 3, -2, minus 2. All right, it's okay to use your calculator. So you have -6, -2, -8. So then you have f of -8. So then this -8 goes in for the f of x. So we have 2 -8 plus 1 all over -8 plus 5. And again, like I said, perfectly fine to use your calculator. And that will equal, I'll put it down here, that will equal 5. Okay? Because you have -16 plus 1, -15, -8 plus 5, -3. So the next one is f of g of 2. So now it's 3, 2 minus 1, 2. Okay? Because you have to plug in the g of 2 first. And this gives you 4. So then you have f of 4. So we have 2 times 4 plus 1 all over 4 plus 5. So that gives you 8, 9 over 9, which is 1. This was 5. Okay, and the last one is f of g of x. Oh, I'm in the way. So that means that you are taking your entire g of x and plugging it in for f of x. So your g of x is 3x minus 2. So we have 2, 3x minus 2 plus 1 all over 3x minus 2 plus 5. The top one I put in parentheses because of the 2 by the x. The denominator I don't because it's just an x. So don't forget you have to distribute that 2 to both of them. So you have a 6x minus 4 plus 1 all over 3x plus 3. Okay? Because I combined these two. So then this equals, I'm going to run out of space. This will be 6x minus 3 all over 3x plus 3. And you would go further and factor out a 3. I know they don't, but they're going to want you to. So I'm just going to put it down here. I'm going to take out a 3, and you have a 2x minus 1. Take out another 3, and I have an x plus 1. And these cancel. This is the answer I'd be looking for right there. Okay. Inverse. Formula for the inverse. Very guaranteed to be on there. Remember the inverse? You switch the x and y, and then you solve for y. So I have x equals y over y minus 2. They like giving you these problems because these are the ones that the students have difficulty with. So you want to get the y's on one side. In order to do that, you have to cross multiply. So put the x over 1. So you have y equals x times y minus 2. Okay? And parentheses there. Then you have y equals x, y minus 2x. Distribute. Bring the xy over so all the y's are on one side. Y minus xy equals negative 2x. Get the y alone, factor out a y. 1 minus x equals negative 2x. I know I'm flying, but you can replay it. Okay, and then I divide both sides, and I will get a y equals negative 2x all over 1 minus x. And that is the inverse. The next one, same thing. Change your x and y. So I have, let's get rid of that. I don't know if I can. No, I thought that was the eraser. So I'm going to make it x equals y plus 3 over 2y. That's a y. Okay. Cross multiply, and you have 2xy equals y plus 3. So then bring over the y, so you have 2xy minus y equals 3. And factor out a y, and you have 2x minus 1 equals 3. Divide both sides by 2x minus 1. Y equals 3 all over 2x minus 1. And that is the inverse. Okay. The last problem, exercise 6. We want to determine if the function is even or odd. Remember, an even function is reflected over the y-axis. An odd function is a reflection about the origin or a rotation. Determine which it is and justify. What type of symmetry must this have? Use your calculator to sketch the graph to verify. So I've already plugged it in the calculator and on the graph page. And so we are going to graph it. So there you have it right there. So clearly it is not an even function, because an even function would be, like I said, a reflection over the y-axis. So if we want to verify that's an odd function, you want to go to your table. Okay, Control T. So we're going to try to find a value, okay, that is going to work. And now when you run into this problem here, okay, you see how we have no whole numbers as an output. So there's no whole numbers as an output. So we are going to adjust our table because I saw a part or a 0.5. So I'm going to edit the table settings. Table start at -3, which is fine. My table step is going to go to 0.5. I'm going to hit OK. So it should, there it is. So at 0.5, let me find, okay, so at 2 is a -0.5. And why doesn't it have, okay. And it doesn't have it on there. Oh, there it is. And -2 is a 0.5. So we had 2 equals your -0.5. And then -2 was a 0.5. So that means that we have 2 is a 0.5. And I think -2, let me double check that. I think one of those is supposed to be negative. So at 2 we had the -0.5. Okay, and at -2 we had the 0.5. So when this occurs, so you see how my x value and y value are the same, absolute value wise, okay, but they switch the sign. So the 2 goes to a -2, the -0.5 goes to a 0.5. So when that occurs, when both signs have changed, that is going to give you an odd function. Okay, I know that was kind of a little tricky, but you can see me in class. We can go over how to get to your table. So you see I did menu, table, and then edit table settings, and I did by a 0.5. Okay, so if there's questions on that, we can go over them in class. Otherwise, hopefully you're not watching this an hour before or a half hour before class, but at least it's done. So I will see you Monday.